Fusing a surge protector is not a common practice and is generally not recommended. Surge protectors are designed to protect electrical equipment from transient voltage spikes, such as those caused by lightning strikes. Fuses, on the other hand, are designed to protect electrical circuits from overcurrent conditions. When a surge protector is fused, it means that a fuse is placed in series with the surge protector. If the surge protector experiences a voltage spike that is high enough to blow the fuse will open and disconnect the surge protector from the circuit. This will protect the surge protector from damage, but it will also render it useless until the fuse is replaced. It is possible that the surge protector was fused as a way to protect the surge protector from damage in the event of a lightning strike. However, this is not a common practice and it is not recommended. The better approach would be to use a surge protector that is rated for the voltage and current levels of the circuit it is protecting. Since the surge protector is still under warranty, it is recommended to contact the manufacturer to get their opinion on the matter. They may be able to provide more information about the purpose of the fuse and whether or not it is necessary. To elaborate further, surge protection devices, or SPDs, are designed to limit transient voltages and divert surge current to ground, protecting sensitive equipment. These devices typically use components like metal oxide varicers, or MOSFETs, silicon avalanche diodes, or SADs, and gas discharge tubes, or GDTs, to clamp the voltage. Fuses are current-limiting devices that protect equipment from overcurrent conditions. They are designed to open a circuit when the current exceeds a predetermined value. The issue with fusing an SPD is that a surge event is a very short duration, high current event. A fuse, depending on its characteristics, might react to the surge current and open, disconnecting the SPD from the circuit. This defeats the purpose of the SPD, as it can no longer protect against subsequent surges until the fuse is replaced. Furthermore, the fuse itself introduces impedance into the circuit, which can reduce the effectiveness of the SPD. The small amount of impedance may not be much, but it is still worth noting. There are several reasons why fusing an SPD is generally not recommended. Firstly, it can render the SPD useless after a single surge event. Secondly, it can introduce impedance into the circuit, reducing the effectiveness of the SPD. Thirdly, SPD are designed to fail safely, typically by shorting out. This will cause a large current to flow, which will trip the circuit breaker protecting the circuit. This is a much more reliable way to protect the circuit than relying on a fuse to blow. If overcurrent protection is desired for an SPD, it is better to use a circuit breaker specifically designed for this purpose. These circuit breakers are designed to handle the high surge currents without tripping unnecessarily. They also provide a higher level of protection than a fuse. When selecting an SPD, it is important to choose one that is properly rated for the voltage and current levels of the circuit it is protecting. The SPD should also be installed in accordance with the manufacturer's instructions. If there are concerns about the SPD being damaged by surge currents, it is better to use a higher rated SPD than to fuse it. SPD are typically rated by their surge current capacity, which is the maximum surge current the device can withstand without being damaged. The surge current capacity is measured in kiloamps, or Ka. Common surge current ratings for SPD are 10 Ka, 20 Ka, 40 Ka, and higher. The appropriate surge current rating for an SPD depends on the application and the level of surge protection required. For example, a surge protector used to protect sensitive electronic equipment may require a higher surge current rating than a surge protector used to protect lighting fixtures. Some manufacturers do offer fused SPD, but these are typically specialized devices designed for specific applications. These fused SPD typically use fast-acting fuses that are designed to open quickly in response to a surge current. However, even with these fast-acting fuses, there is still a risk that the fuse will open unnecessarily. Therefore, it is still generally recommended to avoid fusing SPD whenever possible. Instead, focus on selecting an SPD that is properly rated for the application and installing it in accordance with the manufacturer's instructions. Proper grounding is also crucial for effective surge protection. The grounding system should provide a low impedance path for surge currents to flow to ground. This will help to minimize the voltage rise in the protected equipment and reduce the risk of damage. The National Electrical Code, or NEC, provides detailed requirements for grounding electrical systems. It is important to follow these requirements to ensure that the grounding system is properly installed and maintained. Article 250 of the NEC covers grounding and bonding. It provides requirements for grounding electrode systems, grounding conductors, and bonding conductors. The NEC also requires that all electrical equipment be properly grounded. This includes equipment that is connected to a surge protector. Another important aspect of surge protection is coordination. Coordination involves selecting and installing SPD in a way that ensures that they work together to protect the entire electrical system. This typically involves installing SPD at multiple levels of the system, starting with the service entrance and working down to the individual equipment. SPD installed at the service entrance are designed to protect the entire electrical system from large surge events, such as lightning strikes. SPD installed at the branch circuit level are designed to protect individual equipment from smaller surge events, such as those caused by switching loads. When coordinating SPD, it is important to select devices that have compatible voltage protection levels. The voltage protection level, or VPL, is the maximum voltage that the SPD will allow to pass through to the protected equipment. The VPL should be low enough to protect the equipment from damage, but high enough to prevent the SPD from clamping unnecessarily. The VPL is typically specified in volts. In summary, fusing surge protectors is generally not recommended due to the risk of rendering the SPD useless after a surge event and the potential for introducing impedance into the circuit. Instead, it is better to select an SPD that is properly rated for the application and install it in accordance with the manufacturer's instructions. Proper grounding and coordination are also crucial for effective surge protection. Consider the specific requirements of the electrical system and consult with a qualified electrician or surge protection expert to determine the best approach for surge protection. Remember that surge protection is just one aspect of a comprehensive electrical safety plan. Other important aspects include proper wiring, grounding, and overcurrent protection. By addressing all of these aspects, it is possible to create a safe and reliable electrical system. Some additional points to consider about surge protection include, firstly, the type of equipment being protected. Sensitive electronic equipment, such as computers, televisions, and medical devices, typically require a higher level of surge protection than less sensitive equipment, such as lighting fixtures and appliances. Secondly, the location of the equipment. Equipment located in areas that are prone to lightning strikes or other surge events may require a higher level of surge protection. Thirdly, the cost of the equipment. The cost of the equipment being protected should be factored into the decision of how much to invest in surge protection. Fourthly, the potential consequences of equipment failure. If the failure of the equipment could have serious consequences, such as a loss of data or a disruption of critical services, then a higher level of surge protection may be warranted. Fifthly, the frequency of surge events. If surge events are common in the area, then a higher level of surge protection may be warranted. Sixthly, the type of surge protector. There are many different types of surge protectors available, each with its own advantages and disadvantages. It is important to select the right type of surge protector for the application. Seventhly, the installation of the surge protector. The surge protector should be installed in accordance with the manufacturer's instructions. Proper installation is essential for effective surge protection. Eighthly, the maintenance of the surge protector. Surge protectors should be inspected regularly to ensure that they are functioning properly. Some surge protectors have indicators that show when they have been damaged and need to be replaced. Ninthly, the warranty of the surge protector. The surge protector should have a warranty that covers defects in materials and workmanship. Tenthly, the reputation of the manufacturer. Choose a surge protector from a reputable manufacturer with a proven track record of producing high-quality products. When evaluating surge protection options, it's also important to understand the different types of surges that can occur. There are several types of surges, including lightning surges, switching surges, and utility grid surges. Lightning surges are caused by direct or indirect lightning strikes. They are the most powerful type of surge and can cause significant damage to electrical equipment. Switching surges are caused by the switching of electrical loads such as motors, transformers, and capacitors. They are typically less powerful than lightning surges, but they can still damage sensitive equipment. Utility grid surges are caused by events on the utility grid, such as faults or switching operations. They can range in magnitude from small to large and can affect a wide area. In addition to selecting the right type of surge protector and installing it properly, there are other steps that can be taken to reduce the risk of surge damage. These include, firstly, using surge-protected power strips. Surge-protected power strips can provide surge protection for multiple devices connected to a single outlet. Secondly, unplugging electronic equipment during thunderstorms. This can help to protect the equipment from lightning surges. Thirdly, installing a whole house surge protector. A whole house surge protector can protect the entire electrical system from surge events. Fourthly, using a dedicated circuit for sensitive electronic equipment. This can help to isolate the equipment from other electrical loads that may cause surges. Fifthly, keeping electrical wiring in good condition. Damaged or frayed wiring can increase the risk of surge damage. Sixthly, avoiding overloading electrical circuits. Overloading circuits can cause voltage drops, which can increase the risk of surge damage. Seventhly, using a power conditioner. A power conditioner can help to filter out noise and voltage fluctuations from the power supply, which can improve the performance and lifespan of electronic equipment. Eighthly, installing a UPS or uninterruptible power supply. A UPS can provide backup power in the event of a power outage and can also protect equipment from surges. Ninthly, using shielded cables. Shielded cables can help to reduce the amount of noise and interference that can affect electronic equipment. Tenthly, grounding all metal enclosures. Grounding metal enclosures can help to protect people from electric shock and can also reduce the risk of surge damage. Ultimately, the best approach to surge protection is to combine multiple strategies. By using a combination of surge protectors, proper wiring practices, and other protective measures, it is possible to significantly reduce the risk of surge damage to electrical equipment. Another important concept to understand is the difference between surge protection and power conditioning. Surge protection is designed to protect equipment from voltage spikes, while power conditioning is designed to improve the quality of the power supply. Power conditioners can filter out noise, voltage fluctuations, and other power quality problems that can affect the performance and lifespan of electronic equipment. While surge protection is essential for protecting equipment from damage, power conditioning can also be beneficial, especially for sensitive electronic equipment. Some power conditioners also include surge protection features, providing both surge protection and power conditioning in a single device. When selecting a power conditioner, it is important to choose one that is appropriate for the type of equipment being protected and the power quality problems that are present. There are many different types of power conditioners available, each with its own advantages and disadvantages. Some common types of power conditioners include line conditioners, voltage regulators, and isolation transformers. Line conditioners are designed to filter out noise and voltage fluctuations from the power supply. Voltage regulators are designed to maintain a constant output voltage, even when the input voltage fluctuates. Isolation transformers are designed to isolate the equipment from the power supply, which can help to reduce noise and improve safety. In addition to surge protectors and power conditioners, there are other types of devices that can be used to protect electrical equipment from power quality problems. These include, firstly, harmonic filters. Harmonic filters are designed to reduce the amount of harmonic distortion in the power supply. Harmonic distortion can cause a variety of problems, including overheating of equipment, reduced efficiency, and increased risk of equipment failure. Secondly, power factor correction equipment. Power factor correction equipment is designed to improve the power factor of the electrical system. A low power factor can increase energy costs and reduce the capacity of the electrical system. Thirdly, transient voltage surge suppressors, or TVSS. TVSS devices are designed to protect equipment from transient voltage surges. TVSS devices are similar to surge protectors, but they are typically designed for specific applications such as protecting motors or transformers. Fourthly, emergency power systems. Emergency power systems are designed to provide backup power in the event of a power outage. Emergency power systems can be used to power critical equipment such as medical devices, computers, and communication systems. Fifthly, lightning protection systems. Lightning protection systems are designed to protect buildings and equipment from lightning strikes. Lightning protection systems typically consist of lightning rods, grounding conductors, and surge protectors. Sixthly, grounding and bonding systems. Grounding and bonding systems are designed to provide a low impedance path for fault currents to flow to ground. Proper grounding and bonding are essential for electrical safety and can also help to reduce the risk of surge damage. Seventhly, regular electrical inspections. Regular electrical inspections can help to identify and correct potential electrical problems before they cause damage or injury. Electrical inspection should be performed by a qualified electrician. Eighthly, proper wiring practices. Proper wiring practices are essential for electrical safety and can also help to reduce the risk of surge damage. Wiring should be installed in accordance with the National Electrical Code, or NEC, and other applicable codes. Ninthly, surge protection audits. Surge protection audits can help to identify and correct weaknesses in the surge protection system. Surge protection audit should be performed by a qualified surge protection expert. Tenthly, continuous monitoring of power quality. Continuous monitoring of power quality can help to identify and correct power quality problems before they cause damage or injury. Power quality monitoring equipment can be used to measure voltage, current, harmonics, and other power quality parameters. By implementing these measures, it is possible to significantly reduce the risk of electrical problems and protect electrical equipment from damage. Remember that electrical safety is an ongoing process that requires constant vigilance and attention to detail.